Hey everyone, Mrs. Slauson. So we are moving on in Algebra 2. So just kind of recap of the things that we've talked about so far. In our first week of stuff, we talked about what is a function, what isn't a function, and if it is a function, is it one-to-one? We also talked about evaluating and solving a function. You might look at it with a graph, you might look at it in a table or an equation. And then our last section, we talked about interpreting graphs. So when we read a graph from left to right, is it increasing, decreasing, is it positive, negative, etc. There was that new thing called end behaviors. And now we're going to get into a little bit more review stuff. So today's video, besides of what I've already talked about, is about linear functions. So I'm going with the idea that you do know how to graph a line. Instead of graphing a full line, we're going to actually graph it with a restricted domain. So when we look at our graph, we're not going to graph the whole line, we're just going to graph a section from one part of x to another part of x. So we're going to go in a certain domain. So let's just do a real quick recap. So remember, a linear equation is y equals mx plus b, and we're going to be using f of x instead of y. So just remember those are the two things. When you look at all the letters in here or here, x and y are just ordered pairs that are on the line that you graph. And when you put the ordered pair into your equation, it's going to make the left side equal the right side. So I'll show you again what that means in a little bit. The other thing is you've got your b, that's known as the y-intercept, and your y-intercept is the line that goes up and down, and this is where we will be beginning to graph our line. And then m is known as your slope, that is your rise over your run. And just to recap, remember, positive slopes go uphill, put arrows please, negative slopes go downhill, and then you might have no slope. So this is just a constant, and that was one of those words in the last section. If something's constant, that's supposed to be flat instead of going uphill. So just real quick, how do we graph a line? Well, you need to identify your y-intercept, where you begin, your slope, and that's how you're going to get more points. So let me write this here, more. And then you just follow this pattern of rise over run. So my y-intercept is 4, and that's where I'll begin. And I will rise 1 and run over 2, and I just got to make sure that since that fraction is positive, that my slope is a positive line. So from here, to get more points, I'm going to rise 1 and I'm going to go to the right 2. And it doesn't matter if you go up or down, it's more about the left or right, because you just want to make sure that when you start connecting your points that you have an uphill line. So I'm just going to keep this pattern up 1 over 2, up 1 over 2, up 1 over 2, and the other way. And it's always a good idea to fill your whole graph paper with as many points as possible. And then you connect the lines. Remember, a line is continuous, it never ends. If a shape is broken up into pieces, then that's called discrete. All right, so what I was just talking about here is if I take any of these ordered pairs, so I'm just going to take, for instance, 2, 5. If I take that coordinate 2, 5, and I put it in here, so x will get 2, f of x, which is y, will get 5, and I do the math, the left side should equal the right side. So just on this side, I follow the order of operations. Half of 2 is 1, and 1 plus 4 is 5. So any ordered pair on that line as coordinates should go in for x and y. You do the math, and the left side should equal the right side. So now that we covered that, let's just talk about how we're going to graph in a more specific domain. So I don't want the whole line, right? I just want a piece of it. So just review of graphing another line. I'm going to have my y-intercept of 3, so I begin at 3. I'm going to have a rise of 2. And a run of 5, and this is negative, so it's going downhill. Again, this is all review. You have graphed lines since middle school. So this time I'm going to rise 2, and to get that downhill look, I'm going to need to make sure I go to the left. 1, 2, 3, 4, 5. So I'm just going to fill up my whole paper. It's 2, 1, 2, 3, 4, 5. And then one more, and I end up right here. So right now, by putting these arrows on, even though my graph paper is ending, technically the line is not because it's continuous. So I can only show much of a graph paper. So now what I'm going to do is I'm going to graph this line, but I'm only going to graph part of it. So I think I have a pencil in here that does not have much of an eraser. So what I'm going to do is graph this next version of it in pencil. So I'm going to go ahead and graph the whole thing. So I can actually just, look over to what I just did. All right, so instead of wanting this whole line, I've put a restriction on my domain, and I only want the part of the graph where all the x's are bigger than -5. So I need to go where all the x's are -5. So I'm going to take a little break, and I'm going to tell you a story, because a lot of people think if x is -5, that I should go to -5, right? And then since the x-axis goes left and right, then I'm drawing a line left and right. But that's not really x is -5. So I had a student many years ago, like a long time ago, and she once made up the story. And basically what we're trying to do is graph the line x equals -5. So the opposite of that is y equals -5. So what she would tell me is that x and y are in this long distance relationship, and when they get together and one has to leave, the other one gets really upset. So they go to the airport and y gets on the plane, and she would say, so as y flies by, so if it's y equals a number, your line goes like this. And then she would say, so as y flies by, x is depressed, you're feeling down. So x equaling a number, your line should actually be going up and down. So what I'm going to do is draw the line x equals -5. And I'm going to make this stand out. And the reason why this is, again, x equals -5 is because every point on this line has an x-coordinate of -5, while the y-coordinate is always different. But I just like to remember y flies by, x is depressed, and it's easier for me. So normally, instead of this whole line, I only want the part of the line where x is greater than -5. So I actually only need this part. So I'm just going to go from this dot and this way. And if you remember when you would graph inequalities, if this is greater than, you use an open circle, and if it's greater than or equal to, you would close that circle. So I don't want to include -5, so I'm going to put an open dot there, like we would, again, if we were graphing inequalities. So I actually don't need this dot. I really don't need this line, but I just put that there as something you could see. All right, so a few more, and then these notes are going to be done. And then there's one more video to watch. It should be short. All right, so now I'm going to graph the line -x plus 8, and in between two lines. So let's go ahead and just practice graphing the line itself. So I'm going to begin at 8. And then, even though you don't see it, there is a -1/1 in front of that x, that slope. So you do have a slope, so you're going to rise, and you're going to run, and since it's negative, we're going to go downhill. So I'm going to switch to pencil, because again, I don't want this whole thing. So I'm going to go up 1/1. This is a pretty fast one to do. So I'm just going to fill my whole graph paper with dots. And again, I don't want this whole thing. I want from x is 0 to x is 7. So I'm going to go to where x is 0. Here's an x is depressed line. And then I'm going to go to x is 7 and draw its x is depressed line. And the only part of the line that I want is in between these two. And 0, this is less than, so I'm going to make an open dot here. And when I go to the 7, I'm going to put a closed dot like that. So 0 is not included, but 7 is included. All right, so let's just try this one. So here we're going to write the function, and we're going to give its domain. So we're going to practice writing the equation. So again, when I write the equation, there's the y equals, and I need mx plus b. And whenever you're going to be asked to write an equation, and it's going to happen a lot this year, you leave y as y, or f of x, and you leave x as x. And it's the other letters that get the numbers. So I'm going to go first for b, what my y-intercept is, and it's -8, so I'll put plus -8. And then I need my slope. It's positive because it's going uphill, and I'm just going to see, how many do I have to rise and run to get from one easy point to another easy point. And I note my scale, it is going up by ones and over by ones. So I'm going to rise 1, 2, 3, and over 1. So I'm just going to put a positive 3 there. Now, it's not the whole line. I need to see where they, started this and stopped it. So I'm going to put an X through it here and here. So this is the line, X is -1, and it's between, and you write between with X and 2 less than signs. That means between. You can't switch the signs. They can't be, I don't know if you're seeing this right, they can't be greater than. So the line is going to be graphed between -1 and then 3. And since 3 has an open circle, I will not underline, but since -1 has a closed circle, I will underline. All right, just a little bit more, and then these notes are done, and I'll go over what you need to do. So a car has a 16-gallon gas tank. On a long highway trip, gas is used at a rate of about 2 gallons per hour. And the gallons of gas in the car's tank can be modeled by the function. So I didn't give you the function, so we're actually going to create the function. So if you think about it with the gas tank, in y equals mx plus b, b is always the beginning amount. It's where you start. So we're going to assume that this gas tank is full, and we are starting with 16 gallons. So 16 is going to be my b. And then your slope is how it changes. So we're losing gas at about a rate of 2 gallons per hour. And since it's going down, we're going to make sure that that's -2. And per hour would just be over 1, and -2 divided by 1 is just this -2. So the way you could think about this is they want G to be gallons, and T is the time in hours. So instead of f of x, I'm going to do G of t, like this. All right? The number of gallons depends on the time. Time is your independent, that's your x. G is your dependent variable, so that's your y. So I like to write it this way. I start out with 16 gallons, and then I lose 2 gallons every hour. So now that we got the equation, we're going to answer the rest. So I kind of already answered some of these things. So what's our slope? It's this -2 over 1. And what it means is, again, y's are on top in slope, or average rate of change, and x's are in the bottom. And I already said that the gallons, this number of gallons, that's your y, and your time, that's like your x. So if you just do a little comparison, the denominator are your hours, and your top are your gallons. So now I'm going to put this in context. So we lose 2 gallons, and it's losing because it's negative, every, or you could say per 1 hour. All right, the bell's going to ring here in about 3 minutes, so just deal with it when it rings. So what's the y-intercept, and what does it represent? Well, the y-intercept was the 16. And that 16 means we start with, I'm going to abbreviate, 16 gallons in the tank. So now let's do this. We haven't had this pop up yet as a question. So in this equation, if I put 2 in here and do the math, supposedly I should get 16. So that's actually not true. So if we put 2 in there, we should actually be getting 12. So little typo, please fix that. So if you put 2 in here, because that's your x, that's your t, 2 times 2 is 4, and 16 take away 4 is 12, not 16. So that's a typo on my part. So what does the ordered pair mean? Well, remember, this is your time, this is your minutes, and this is the number of gallons that you have. So just writing that is not enough. You need to put this in a sentence. So after, it's not minutes, my mistake, it's hours. So after 2 hours, the car has 12 gallons of gas. So make sure you write a full sentence. What is the x-intercept, and what does it represent in context? So we haven't talked about this either. So all x-intercepts, it hits the graph, and maybe you remember this from when we did our important points. All x-intercepts, while x has a value, y is always 0, okay? So when I say what is the x-intercept, I'm asking you to tell me, that means if y is 0, I want you to tell me what x is. And again, y is the number of gallons. So over here, where y normally is, this g of t, excuse me, I'm going to put 0. And then I'm going to solve for x, which is me actually just solving for t. And so I need to isolate the variable. To avoid all the subtraction of negatives, I'm just going to add the 2t to the other side. And now to get t alone, I'm just going to divide by 2. And t is 8. So my x-intercept is actually 8, 0. And now I'm going to answer the question just like I did here. After 8 hours, the tank is empty. So again, if I ask you for the x-intercept, I'm actually telling you why. Because all x-intercepts have a y value of 0. Hint, hint, listen to that. That's going to be one of your questions right about now. Okay, so let's talk about what's going to happen now. So we're going to kind of switch things up. And I really think at this point, things might be getting a little more difficult for some of us. And so what I want you to do is this practice on page 20. And in the Schoology folder, when you do the practice, I will actually have a PDF of this answer page. So you'll have seen, hey, step 1, watch the video. Step 2, do the practice. And now that you've done the practice, you're going to see a link for an attachment with the answers. The goal is not to copy the answers. I want you to try the practice first and then see how it goes. I want you to know if you're getting it right or wrong. So you will not be submitting this to OneNote. Instead, what I'm going to ask you to do, and it should have said it already, is I want you to take a picture of your notes on page 18 and page 19, and you're going to see a link in OneNote for this, and I want you to submit those notes. All right? The homework you don't have to submit, but I am asking you to try it and then check your work. So don't not do it, because that's not going to fare well for you in the end. It will most likely just blow up in your face. So please do the practice. There is one more video. It's pretty short. So if you want to take care of this first and then go into the second video, that's great. Our second video is going to be starting on page 22, and I'll be covering page 22 and 23. And that's going to be graphing an absolute value function. And then we'll save this for later. So you'll have 2 videos this week. That's it. And see you in the next video.